A single honeybee can fly, collect food, produce wax, and communicate with other bees. But no individual bee can maintain brood, regulate the temperature of the nest, create food reserves, and ensure the survival of the next generation on its own. Those abilities emerge only when thousands of individual bees begin to function as one interconnected whole. That is why biologists often describe the honeybee colony as a superorganism. A superorganism is not simply a large group of individuals living in the same place. It is a system in which different members perform specialized functions, exchange information, and collectively sustain the life of the entire colony. In the human body, different organs perform different tasks. The heart circulates blood. The lungs enable gas exchange. The stomach and intestines process food. The nervous system transmits information and coordinates responses. No single organ can independently represent the entire organism. In the same way, no individual bee represents the entire honeybee colony. The queen performs most of the reproductive function. Worker bees maintain the nest, feed the brood, produce wax, process food, defend the entrance, and collect resources. Drones have a reproductive role and transfer genetic material between colonies. Each group has a different function, but none can exist over the long term without the whole. The strength of the superorganism is not found only in the division of labor. It is found in the ability of thousands of bees to respond to needs that no individual bee can fully perceive. When the brood lacks food, more workers begin to participate in pollen collection. When the temperature in the brood area falls, bees generate heat through the activity of their thoracic muscles and gather around the sensitive part of the nest. When the temperature becomes too high, workers bring water, distribute it throughout the hive, and use their wings to promote evaporation and airflow. There is no single bee issuing all of these commands. The colony adapts through local signals, physical contact, odors, food exchange, vibrations, and the behavior of a large number of individuals. Each bee responds to a limited portion of the available information, but the combined effect of those responses produces an organized reaction from the entire colony. We call this self-organization. Self-organization allows the colony to change the distribution of work without a central command center. Younger workers most often perform tasks inside the nest, while older workers gradually transition to guarding the entrance and collecting food. However, this arrangement is not completely fixed. If the colony loses a large number of foragers, younger bees may begin foraging earlier. If more nurse bees are needed, some workers may continue performing brood-related tasks for a longer period. For this reason, the division of labor is not a simple factory production line. It is an adaptable network that continually changes according to the condition of the colony. The honeybee colony displays another characteristic of an organism. It maintains internal conditions despite changes in the external environment. Temperature, humidity, airflow, food availability, and the balance between brood and adult bees are continuously regulated through collective behavior. An individual bee has a limited lifespan, but the colony can persist for years, replacing generations while maintaining its organization, resources, and biological continuity. Even colony reproduction takes place at the level of the whole. When a colony swarms, it is not simply one bee that leaves. A portion of the organized population leaves the original nest with the queen and begins a new colony, while the remaining bees continue the life of the original colony with a new queen. For this reason, swarming can be understood as the way in which the superorganism reproduces. Understanding this principle changes the way a beekeeper views the hive. We do not evaluate only the queen, the amount of brood, or the number of frames covered with bees as separate pieces of information. We evaluate how all parts of the system function together. A good queen is not enough without an appropriate population of worker bees. A large population is not enough without sufficient food. Abundant food reserves are not enough if brood development, colony health, or the hive microclimate is compromised. A beekeeper who sees only the individual parts may overlook the true condition of the colony. A beekeeper who understands the superorganism looks for the relationships between those parts. The honeybee colony, therefore, does not function as one because all bees perform the same task. It functions as one because different bees perform different tasks in service of the same biological system. In the next lesson, we will meet the central reproductive individual within that system and explain the true role of the queen in the honeybee colony.